In this question, you are asked to plot a graph of D2 against D1. Each time you're asked to plot a graph, do take note that the first quantity that's being mentioned is always your y-axis or your vertical axis, and the second quantity that's being mentioned is your x-axis, okay, or the horizontal axis. So D2 will be on your y, D1 will be on your x, and you will be able to get your 1 mark for axis. So A, you will score 1 mark if you write D2 and D1, and do remember that you have to include the units as well. So over cm, okay? And to get your S, remember your ASPL. So to get your marks for scale, you've got to ensure that your graph covers at least half of the space that's given. So in this case, it will only be possible if you use a scale of, for your x-axis, interval of 5. Now, do note that the interval should be in intervals of 1, 2, 5, or the factors, so or 10, 20, 50. Okay, try the other numbers will make it difficult to plot, and some awkward numbers like 3, 7, and so on, or intervals of 3, 7, and so on, you will actually end up getting no marks for plotting and no marks for scale. So in this case, this interval is 5, okay, which is good. If you start from 0, it is okay, just that your very last plotting of 35 will be here, but that's fine. And then your D2 axis, interval of 2. So in this case, you got to start from 4, or you could start from 6. But if you had started from 0, you find that you will not have enough space to plot all the points. So again, please remember that your x-axis and your y-axis do not need to have the same interval. So in this case, the interval here is 2 on your y-axis. The interval here for your x-axis is 5, and that's perfectly all right. And you also don't have to start from 0. Okay, so in this case, your y starts from 4, your x starts from 5. That's perfectly all right. But it's important that you label this point, because a lot of students forget to label the starting value, and then they lose marks from A. So scale is taken care of, A is taken care of. So plotting, remember to plot with neat crosses, not too big, not too small. And if you plotted wrongly and you erase, make sure that you erase it very clean. So plotting. So if I plotted accurately, this is how it looks like, and this is a straight line. And then drawing a straight line. In this case, the points are all quite, the line is quite close to all the points here. Determine the gradient. Now, to determine gradient, you must show the working. I know in math, you can just take the first point, last point, substitute into the formula. But in physics, you can't. So the first step is you've got to find a point that is on this line itself. Okay? Doesn't need to be the plotted points. In fact, sometimes plotted point may not be ideal, because that point that you put across may not be even on the line itself. So for me, I've chosen this point. Okay, and the reason why I choose that point is because it is easy to read the values, and so that is and then I got to label whichever point I choose. I must label the coordinates, and don't forget, when you label, is your x and then your y. So this is 34, 22. So this is x. Maybe I call this x1, y1, right? I need to look for another point that is somewhere around here, because the 2 points that I use to find gradient must be as far apart as possible. So I've decided to choose this point here. Sorry, a little hard to do on the screen. Okay, so sorry, this part should be drawn nicer. So I've chosen this point here, And again, I must write its coordinate, and that is x2, y2. So x2, y2. It is good for you to put your x2, y2, x1, y1, so that later on when you substitute, there's less tendency for you to make mistake. So if you have drawn a big dotted triangle, you have labeled the coordinates accurately, you would have scored 1 point for gradient. And the next thing you do is, of course, to do a calculation. So gradient is y1 minus y2 over x1 minus x2. And it's easier to carry on now because you have labeled all the necessary points. So 22 minus 6.4. That's for me. If you have chosen two other points, your reading should still be about the same as my value. And I have 0.65 as the answer. Okay. I think the answer sheet says 0.64. I think it's fine. And so the next thing, so just write the gradient. And again, by showing this working, you would have scored another 1 mark. And the next part require you to, okay, the next part says, what happens when you hang a 20 Newton weight at 18 cm from the pivot? So if you look at the picture, 18 cm from the pivot. So the place where you hang the 20 Newton weight, it is D1. So basically it's just another way of telling you that what happens when D1 is 18 centimeters. So I will show it on my graph. So this is 18, right? This is 18. If you read carefully, this is 18. Again, I got to show with my dotted line working, and then I must label the value here on the graph itself. So in this case, my value is 11.6. It shouldn't vary too much for you. But if I put 11.6 as the answer, you won't get the marks because the question did not ask you for D1. The question says, they ask for the distance between D1 and your hanger. So therefore, D1 plus, so this is 18, right? This is 18 here. The hanger is your D2. So D2 is 11.6. So you have worked out this 11.6. So what the question wants is the distance between here and here. So you got to read the question carefully, and then you'll get 29.6. And this part requires you to just do a simple substitution. Don't worry if you have never seen this formula, it's perfectly all right, but you have calculated the gradient. So just use whatever gradient you have calculated, substitute to get the weight. Okay. And the next part says, if you put a strong magnet here, this is an iron hanger. So an iron will be attracted to the magnet. So you expect that there is a force pulling it down, and therefore you will find that this will be turning the rod in a clockwise manner because of the attraction between the iron hanger and the magnet. So if they ask you to describe, you'll say that it turns clockwise. So how do you balance it again? All right, so if you want to balance it again, they said you cannot remove anything. That means the magnet has to be still near to the iron. So what you have to do is, because now it's a clockwise moment, what you can do is either you either decrease the clockwise moment, or you can increase the anti-clockwise moment, so that you try to establish that the clockwise moment equals to anti-clockwise moment again to balance it. But now your clockwise moment is too big, so you need to reduce it. So how can you reduce it? You can actually put your hanger closer, so the distance will be smaller, so your moments will be smaller. So that's one way. So that's what it means by move the hanger closer to the pivot, because in this case, your D, let me see if it's D1 or D2. So in this case, your D2, oops, sorry. So when you move it nearer, your D2 will be smaller. So your anti-clockwise moment will be smaller. Alternatively, you can keep this side the same, and you make this clockwise moment, sorry, make this anti-clockwise moment bigger, right? Because now that your clockwise moment is bigger, you can balance by making the anti-clockwise moment bigger by moving your 20 Newton further away. So this is to increase your D1. So that's also possible. All right. And since the question asks you to explain your answer, you will say that because when you do this, when you move the hanger nearer to your pivot, you will decrease D2, clockwise movement will be smaller, and then um, the clock and anti-clock will be the same and you will balance again. But you have chosen this answer, you will say move the 20 Newton weight further, then you will explain by saying that, oh, then your D1 will be bigger, your anti-clockwise will be bigger, and then you will be able to balance with a new clockwise moment. So that's all for this paper. All the best for your exams.